a quarter ellipse in this case. So let me zoom out. X minimum negative 10, 10, Y minimum negative 10, 10. You can see it is a ellipse because the x-intercept is different from the y-intercept. The length of the x-intercept and the y-intercept are different. So this is an ellipse. So when t equals 0, we have the point 2 cosine 0, which is 1. So when x equals 1, and then y will be 3 sine pi over 2, which is 3 sine pi over 2 will be also 1. So between 2 and 3, we will see a quarter ellipse in this case. So this point starts at 2, 0 and moving counterclockwise to the point 0, 3. So from the formula we can get that the area under the curve is integral from alpha to beta gt f prime t dt, which equals, in this case, from 0 to pi over 2, 3 sine t times 2 negative sine t dt. And this will be equal to negative 6 from 0 to pi over 2 sine squared t dt. And this will also be equal to negative 6.5 integral from 0 to pi over 2 1 minus cosine 2t dt, which is equal to negative 3 t minus sine 2t over 2 from 0 to pi over 2, which eventually we get negative 3 times pi over 2 minus 0, which is just negative 3 pi over 2. So this will be the area under the curve. Is from t equals 0 to pi over 2, we have the area under the curve will be the absolute value of this, which is 3 pi over 2. Okay, so take notes. Feel free to take notes, pause the video. And then now let's move on to the second concept involving calculus. Still using this paper. So now let's talk about arc length. So if a curve is given by a parametric equation, still x equals ft, y equals gt over the interval from alpha to beta, where the derivatives of f and g are continuous in the same interval, and the curve is traversed exactly once as t increases from alpha to beta. And then we can compute the length of the curve with the following integral. L equals interval from alpha to beta square root of dx dt squared plus dy dt squared dt, which you can also write these two as x prime t, y prime t. Just personal preference thing, no big deal. Okay, so now let's move on to an example of this. Oh, and also mention, if the curve is of the form y equals f of x over the interval, the x is over the interval from a to b. You can see it, okay. In this case, the formula will be L equals integral from a to b square root of 1 plus dy dx squared dt. You can also write it as f prime t as a personal reference. Still, no big deal. So now let's move on to the example. So find the arc length of the spiral defined by x equals et cosine t, y equals et sine t over the interval from 0 to 2 pi. So what we're first going to do is first find out the derivative of x in terms of t and derivative of y in terms of t. So in this case we have dx dt equals et cosine t minus et sine t. We have dy dt equals et sine t plus et cosine t. And then using the calculator to help us out, we have the integral of the length of the curve, which is the integral from 0 to 2 pi, because this is the parameter interval of the square root, long one, e to the 2t times cosine t minus sine t squared plus e to the 2t times sine t plus cosine t squared dt. So after we substantiate this from the calculator, let's pull out the calculator, turn it on, go back to the mainframe, and then let's go math 9 to calculate the integral. So in this case we have this, if you want to take note. Okay, we have from 0 to 2 pi square root, a big square root, e to the 2t times cosine t minus sine t squared plus e to the 2t, okay, sine t my plus cosine t squared dt. See what we got. We have this value over here. But what if this problem in the AP test is not allowed? We are not allowed to use a calculator. Then we might not get the exact value, but well, after we calculate this, we have 0 to 2 pi today. We can factor out the et over here, et cosine squared t minus 2 cosine t sine t plus sine squared t plus sine squared t minus 2 sine t cosine t plus cosine squared t dt. Here we have this, and then eventually you will just get from 0 to 2 pi et just square root t 2 dt. Wow, that reduced a lot of stuff. So eventually we'll just get square root 2 times et from 0 to 2 pi, which is just square root 2 e to the 2 pi minus 1. And this will be the answer you will get for that problem. Okay, so take notes. And let's move on to the next example. So this one is kind of tricky. So first, I want you to find the arc length of the circle defined by x equals cosine 2t, y equals sine 2t over the interval from 0 to 2 pi. Sorry if you don't see the question. Okay. So I want you to pause the video to figure out the solution yourself. And I also want you to think about if there is any problem associated with this example. Okay, so it seems like you found out the solution and figure out why there's a problem in here. Okay, so now let's go over it together. So if we apply the formula L equals alpha to beta, this thing